Hi everyone. This is the last session in chapter 4, session 4.4, evaluating the linear model. And in this one, we're going to use linear models to describe association only when appropriate. And we will compute and interpret the coefficient of determination. So what is that? It is R squared. So we have learned the way to find the correlation coefficient, the regression line, and today we're just going to talk about coefficient of determination. That actually also can use can find by square the correlation coefficient, and you can also find by using StatQuant to have this, right? So let's start. So firstly, I would like to talk about the cautionary notes regarding the regression. First, don't use linear models to describe a non-linear association. So something like a parabola, something like exponent, they are non-linear association. So you will not use the linear models to describe this stuff. Okay, and how can I know is that a non-linear or is that a linear models? You need to look at the scatter plots first, right? Always try to do scatter plot first. All right. So okay. Now the correlation is not causation. Okay. An association between two variables is not sufficient evidence to conclude, okay, that a cause and effect relationship exists between variables. So you can conclude a cause and effect relationship exists between variable if you have the correlation, okay? So beware of outlier that can have a big effect on correlation coefficient R. And you have to always check the scatter plot for outlier first, okay? And don't extrapolate, don't make prediction beyond the range of the data, because we are not sure that the linear chain will continue beyond the range of the data. So remember an example in weight and height, right? Yeah, in the case like you have the height was 0, then the weight become a negative. That's not impossible, and that's doesn't make sense. So sometimes you have to think about that. All right. Now let's do example 1. This is an extrapolation, right? So from the previous examples, we found there was a strong linear relationship between height and weight in women, and this is a regression equation. Okay. Now a question is, what weight if we want to predict for a woman who has like the 6-inch tall? Okay, you may pause my video and try to do this in about like 2 minutes, but after that you're gonna see there is something that impossible, right? So let's check. So see that when you plug in the hat as 36 here, you will have the weights become a negative number. So that's again, will not be a a good number, right? Because it's negative, it's become impossible, right? So so you don't wanna like this happen. And so what happened with that? You had to know that the range of the data was for women was from 61 to 68 inches tall, right? You see from the table in the example. So then it is not appropriate to use a regression equation to predict the height for a 36-inch tall woman. And also you should know that 36-inch is beyond the range of the data. And I'm gonna say there's almost no one tall about 36-inch. And if it is, then it's like an odd number. It's like, you know, we don't know. Okay, so let's move to the next. Coefficient of determination is R square here, right? So oh. All right. So I change. I think there is some mistake with the typo here. The square of R, that's going to be coefficient of determination. I don't know, just put this here. Okay. So R squared is a coefficient of determination. Okay. And it usually converts to a percentage. So it's always between 0% and until 100%. So it means how much variation in the response variable is explained by the explanatory variable. So the larger R squared, the smaller amount of the variation are scattered about regression line, right? So so you can see that sometime for the data on car H and predict value, the R will be in here, in this case, a negative 0.778. And if you compute the coefficient of determination R square, you're gonna square that number, right? And that's gonna be equal to a positive of 0.605, and weak mean is 60.5% when you multiply by 100, right? So you see that. So so that means what? I mean, the KH explained about 60.5% of the variation in the K value. Okay. So yeah, I think that's all for this session, and I'm gonna start this chapter now, and I will see you next time. Bye.